Hi guys, welcome to this live session. Today is Wednesday, February 15th. This is for Physics 101. I just want to clarify a few things because I want to go through the things that are needed in this course and how we're going to proceed and answer any questions that you guys would want to have. And then take it from there, basically, especially if you brought up any questions and things like that. I know a lot of you are not live. Some of you actually messaged me saying that you'd rather have the recording basically made so that you guys can watch it later on. So for those who are watching it later, and if you still, this session is not does not clarify anything for you, please message me. And I would be more than happy to answer it to you, or if it benefits everybody else, I would be more than happy to answer it also for the benefit of everybody else for on Canvas so that everybody is on board. So again, this is a Physics 101. It's an algebra-based course, meaning that you really have to have some understanding on how to basically manipulate some basic algebraic equations. So at some point, there will be assignments, homework assignments, so you're expected to be able to do them. We will have labs, of course, in this class. Some of these labs are designated as discussion labs. And what that means is basically we're going to go through problems that we're going to solve. And those problems serve two purposes. First of all, they emphasize the concepts that are covered in the lecture. So meaning once you practice them, once you know how to solve these things, and it should give you a better insight, far more in-depth actually insight into the concepts that are covered. So it's a critical piece of the puzzle to be able to solve problems. Now, solving problems is not an exam, meaning you could consult any resources that you have, whether for the homework or for any discussion problems. We can solve them together, we can think about them together, and then come up with a solution. You could Google it if you want to. You could actually, and this is a great resource that we have here on campus, take advantage of it. It's the STEM Center. If you're not familiar with it, it's in the Physical Science Building, which is where our labs are held, which you're supposed to attend them anyway. It's in the Physical Science Building, the first floor. When you come in through the main gate, you go straight out, continue straight through. Don't go into any of the offices. You will find the STEM Mesa Center. There is some tutoring opportunities in there, specifically in physics. There is always, or on rotation, there is a person in there who should be able to help you with your assignments. Please do take advantage of it, because you are strongly encouraged to do that, to be able to solve those problems. No one, no matter who they are, can claim they can solve any problem without having to basically help. So you should be able to take advantage of that, and don't be ashamed of the fact for asking help. As a matter of fact, you are strongly encouraged, as I was saying. So this is a requirement for this purpose, is to help us understand the concepts. The second point also, and it's equally important, is to help you prepare for the exams. So if the first one is not high enough on your priorities, the second one should be, because you would want to pass this class and pass it with flying colors. So you should be able to do the homework problems, and you should be able to understand them. And come exam time, you should be able to solve those problems on your own, and you should not have any difficulty whatsoever if you go through the process of doing these things. As I was saying, some of these labs have been designated as discussion sessions. And that means that that's where we're going to do mainly our problems. I will not take attendance during those discussion sessions, but that doesn't mean you should not attend. You really should. We will take attendance during the regular labs, but because there is a document for every lab, and I will explain it, that needs to be signed. And that shows attendance, but for the case of the discussion, we don't have that. So in a sense that you may skip it, but don't, okay? Because as I was saying, to serve two purposes. reiterate and emphasize, and to better understand the concepts that are covered in the class. Number two, to prepare for the exam. So it's very important that we do that. Which brings me to another topic in here that is of interest to everybody, and that is the idea of, hold on, I have somebody in here that we need to welcome in. Anyway, so we have another point in here, which is the labs themselves. So we have regular labs throughout the entire semester, with the exception of those discussion sessions that I was saying where we do problem solving. The labs, they're mandatory, they are required. You have to do the labs. If you skip the labs, you will receive an incomplete grade, meaning that you're not going to get a grade by the end of the semester. You will receive an I instead, in which case you will be required to complete the labs in later on time. And once you do that, once you meet the minimum requirement, then you receive your grade added to the lab, and that's going to be your grade for the class. So please do not skip the labs. I know last semester, because of Corona, people thought that, hey, maybe the labs are going to be online. Maybe we're going to do them on Zoom. No. Maybe they are available on Canvas. No. They have to be physically in person in room 214, which is the second floor in the physical science building. So when you come in, before you go into the main entrance, there are stairs that takes you upstairs. And there is an elevator, choose whichever. Either you go through the stairs that takes you to the second floor, or the elevator takes you to the second floor. And then you go through the immediate door. I mean, granted, the physical science has two kinds of sides of buildings. There is the straight building that comes from the parking as you're coming, you see it. And there is another extension that goes there. You don't go to the extension, stay in the main building. You go in, and once you go in, you walk all the way to the end of the hallway again, and it's going to be on your left-hand side if you're coming from the main entrance. And that is room 214. So for section 72, we meet on Mondays from 2:20 to 6 p.m. For section 73, we meet every Wednesday from 4 p.m. to 7:40 p.m. So that you have to know which section you are in. Some of these 72 sections, they're planned to come in here today for section 2, but this should not be a habit. Every person have to stick to their own section, because especially the sizes are slightly off. So we need to make sure that everybody is doing his or her work in the right section as they should be. When I did the syllabus initially, I skipped the fact that this coming Monday is a holiday, so I already scheduled the lab for next week for section 72 and 73. But apparently it's a holiday, so I adjusted the labs for 73, and it's going to be also adjusted for 72 to meet that requirement, in a sense that next week is not a lab. There is no lab for Monday, because there is no class in Monday. It's a holiday. So section 73 is going to benefit from next session of discussions. And that's going to be probably a habit, because most of the holidays are going to be on Mondays. So that's basically something that is going to happen. Now, if you are not in that section, you can attend for the discussion of this coming Wednesday, which is today, I mean, the 15th. So it's going to be the 22nd. Let me check the calendar quickly. Yes, on the 22nd of February, we will have a discussion session for section 73. And regardless of which section, you're encouraged to come in, because we're not going to be doing labs. We're going to be doing problems, and that's going to prepare us for the exam anyway. And so for those who don't make it, it's going to be a little bit hard. So please try to be in. So this is in terms of everything else. So again, and I cannot emphasize how important this is. Labs are in person. You have to be on campus for the lab. You cannot do it on Zoom. You cannot do it remotely, okay? Typically, every lab has a, not typically, always, every lab has a signature form associated with it. So once you do the lab, you don't leave the room, you don't go home until you write your name on it, on that signature form, and then you mark the date on it, and then I sign it for you. Okay, that way shows that you have completed the lab. If you forget that, that is, you have to let me know immediately so that we fix that, okay? So that's how we keep track of the fact that you did your lab or not. Now, if for some reason you cannot make the lab, you can still submit a lab report because every lab has a lab report, okay, associated with it. So you can still submit the lab report, provided you get the data from somebody. Okay, you have to contact your peers, get to know them, and ask for their data that they collected on that day and submit your lab report. Now, you're not going to be able to submit the signature form because you don't have it. But at least it's better than nothing. You will get partial credit, better than getting no credit at all. Okay, in the syllabus, it tells you how many labs can be dropped. So if there is an emergency and you cannot make it there, then you can still basically have that lab dropped. So don't make a habit of also dropping a lot of labs, because if you drop a lot of labs, what's the point in there? If yes, we do. Yes, we have lab today. Yes. Okay. Anyway, I usually, not usually, I always never cancel class. So it's always we have class. We have labs. And when I said that last semester to my students, I never canceled class. I was hit with the with the what is that thing? When you go to the court for the jury duty, okay? So I ended up canceling one of the labs for my astronomy class. So I probably should never say never, but that's the case, okay? We always have labs, we always have classes. So I plan on being there all the time. And if somebody tells you that the instructor canceled class, tell them that's not true. He said he never cancels classes, okay? Okay, which brings me to another point, okay? The lab is kind of small environment. So you are highly recommended to be wearing masks when you come into a lab, especially if you have young people in your home or elderly people in your home. And it's not just because of Corona. There are all kinds of things that can be transmitted, and you don't want to take that home. So for your own safety and that of your family, please wear a mask. You don't have, it's not a I'm going to enforce it, in other words, okay? So if you do come in, please try to make a mask just out of concern to your immediate family. But if you choose not to, I'm not going to basically tell you, no, you shouldn't come in or anything like that. So that's basically what I'm going to say about that. Now, if you really have some sort of experiencing weather or experiencing some sort of other things, it's really far more important that you really have to, first of all, take care of yourself, but then also protect the rest of your peers from anything that you can carry with you. So it's very important that we have to have that. So if you are doing that, I would even no problem, Darius. Anyway, I would recommend that you put a mask then far more than if you don't have any kind of symptoms whatsoever. Okay, and again, it's not just Corona; it's all kinds of things that are out there. Okay, for my sake, for example, I have a wife who is diabetic, and I really don't want to bring home anything, so you will see me with mask all the time. As a matter of fact, every time I enter the physical science building, I have my mask on until I leave it. That's when I remove the mask. So that's something I need to take into account. Again, I know a couple of you came in late. Labs are mandatory and in person all the time, okay? Except during spring break where we don't have labs, or a holiday like this coming Monday for a group of you where we don't have labs. Other than that, we have labs all the time, and they are going to be in person. They are in person actually, and they are on campus. Okay, short of not doing the labs, choosing not to do the labs, you're going to receive an automatic incomplete grade, regardless of how many points you have. You could end up, for example, with a 95 for the rest of all of the other assignment, 95%. But since you're missing the labs, actually, if you account for it, it's going to drop you below the C. I mean, it's going to be a D. So it's not going to be a passing grade if you don't do the labs at all. But for that, you're going to receive an I instead, an incomplete grade, meaning that you have to still do the labs to pass this class. Okay. So this is how we're planning this class. This is how it goes for class being a hybrid, partly online and partly in person. Which brings me to the second component of this class, which is the literature itself. You have all the resources needed for the class on Canvas. You have the discussions, the previous discussions granted. You have the book. You have the summary. You have the quizzes. And you have all of the assignments in there, okay? Something is not clear, for example, something that needs further clarifications, reach out to me, let me know, and then we can arrange for a meeting online. Now, that's not the only place where we can meet in person. My office is Office 195. It's in the Physical Science Building. On the second part that I was not talking, that I told you don't go to, remember, there is a main building of in the main corridor of the Physical Science Building, and there is like a side to it. On the side to it, that's where my office is, in the first floor. When you go in, there is a bunch of offices there for faculty. There is a room 199, which is a lecture room. And then you go into a bunch of offices, and you will see a door that says 194B. You go into 194B, and then you will find two offices, 195 and 196. I am in 195. That's where my office is. Most of the times I am either in lecture or in lab or somewhere else. So if you don't let me know that you're coming, then most likely you're not going to find me in there. Probably you will, but doesn't guarantee that you will. But if you walk in and you find me, I'll be more than happy to answer any of your questions if you have one, okay? And also, I have an office hour between 1 p.m. and 2 p.m. every Thursday in the STEM Center, the one I mentioned in the beginning, and that is in room 145. Okay, again, it's inside the STEM Center. When you go into the STEM Center, way back in the corner there is a small office. That's where I sit on Thursdays between basically 2 and 3. I mean, 1 and 2, I'm sorry. Because at 2 o'clock, 2:10, actually have another class that I have to be in. And that's going to be the lab for another class, for an astronomy class in the same room, 214, actually, but not for you guys. Anyway, so this is basically how my schedule is. If we can't meet, for example, online, if we cannot make it in room 145 in the Physical Science Building, if we cannot meet in room 195, we have Zoom. We can meet anytime, okay? Not on holidays, though. I planned already a meeting with another student from another class, actually an astronomy class, to meet on Friday, but then I was reminded by another chemistry faculty that we can't meet on Friday because it's a holiday. So excluding holidays, any other day is a clear go for me, including Saturday and Sunday. Actually, if we can't find anything, I'll be more than happy to meet with you on Thursday and on Saturday and Sunday, whichever you prefer. So we can meet any time of the other days, and we discuss what you need. Now, during our one-to-one meeting, especially if it's on Zoom, let's say, for example, we discover something that was not clear and could benefit everybody in the class. At that time, I'll ask your permission to record that section, in which case, whatever private information you have in there has to be completely removed, including your name. And then I will record it for the benefit of everybody else. Once we're done, we'll stop recording, and then I post it for the rest of the class, okay? Granted, you okay it. You tell me, okay. If not, I will have to record it on my own by myself, okay? So this is basically the entire process of how to, what to do and things like that. Do you guys have any questions so far before I get into something else? Okay, thank you, Vivian. Okay, so let me share with you the screen so that we have an understanding of what we're covering in this class. So the topics in this class can be grouped into several things, okay? So we're starting with waves for this class, and then we're going to go to mechanics. Does everybody see my screen?
Yes.
Okay, very good, thank you. So mechanics, in here, we're going to study the law of motion, the laws of motion. First of all, we're going to study motion itself, which is a branch of physics called kinematics, and then its laws, okay? And at some point, we're going to get in the concepts of energy and momentum. Okay, so this is basically how the breakdown of the course is. And then after that, we're going to get into an important topic, namely electricity and magnetism. And in here, we're going to understand the concept of Coulomb's law, also magnetism and its origins, and how one changes to the other and vice versa. And we will understand a few things, for example, how to generate electricity using power generators and things like that. But then we're going to get the electrical circuits. We're going to spend a little bit of time in here, and we will have some problems in here to discuss, and probably some things that can be in exams. And after that, we're going to get into kind of modern physics, namely atomic model, and also let me make sure that I'm not in the nuclear physics, so the nucleus, okay? And that's basically in a nutshell what this course is, okay? So this is basically how the course is structured. So yes, modern physics will be another topic that we're going to explore in here. The labs, they follow the sequence more or less, okay? The exams, you have 4 exams, okay? That includes the final. So they follow this format also. The course, as I was saying, is an online course for the lecture, but the labs, they are going to be in person in here, okay? There are some key concepts that you have to really grab from this course. Let me see if I can find some of them. When I talk about the laws of motion, we should be able to basically understand them. And there are 3 laws. And the main law that you're going to really learn from this class, if anybody asks you at all, what did you learn from this class, is force equals mass times acceleration. So this is, if you wish, if you grasp this concept, that's it. You achieved more than 50%, more than 80% of this course, by the way. This is the biggest, most important concept that needs to be developed from this class. Again, we're going to be able to understand. We're going to be able to think in terms of a scientific, in a scientific fashion. We're going to be able to rationalize things, which is one of my biggest things that I really want you to take from this class, is why things the way they are. So thinking is an important aspect of what I always teach. And you will see me in the lab questioning things. And that's what I want you to do. I want you to also question things and come up with a rationale for why the way they should be, why they are the way they are, okay? So that's an important thing. We're going to talk about the scientific principles. We're going to talk about the scientific method. We're going to compare different concepts and what makes them to be concepts to begin with. And the key thing is measurement. If you cannot measure it, it's not physics. It's not physics. That's the key. So if every time I introduce a new concept, every time we see something new, velocity, for example, the first question that needs to pop up to mind is, how do we measure that? If we fail to answer that, then forget it. Why do we have to bother with it? That's not physics. Probably math, or maybe some other philosophy, or maybe some poetry or some other thing, but not physics. I'm not saying bad things about math or poetry or anything like that, but I'm telling you what physics is. Physics relies on measurement. So if it's not measurable, it's not a physical concept. So we should be able to do that too, okay? And then in order to understand things, we build models. And you will see that clear, for example, in modern physics, when we're talking about, for example, the atom, we will build a model and we will see it crumbling against before us for new experiments. So here is a model. So this is, for example, what the atom looked like. And then we're in another experiment and this thing falters. Then we build another model for the atom that accounts for the new experiment and the experiments before. So again, we're doing measurements. And every measurement need to be able to be explained by this model. Now, if this model does not explain the new model, so we have to abandon it and come up with another model. So again, it's a theory, if you wish. It's an approach, and that's how physics is. Always progressing. Every time you come up with a new discovery, you have to explain it. And if you cannot explain it based on what you have to come up with something new to explain it with. And don't forget what you did so far. You have to explain everything that was done up to this point, plus the new thing. Okay. So this is basically in a nutshell what we need to do. And that's why you actually have seen already the divisions. You have classical mechanics. And that can explain everything that was done up to probably the late 1800s. And then modern physics that emerged in the beginning of the 1900s, the 20th century. And it branched into two different physics. Quantum mechanics, and before quantum mechanics, it went through different stages before reaching the final form, and even in relativity. And at this point, we know the story of physics is not complete because these two are incompatible, and somebody has to bring them together. This does its job beautifully in its work, basically for the atom and the nucleus and all of that. And this one does its job beautifully for the large-scale stuff, like, for example, galaxies and the neutron stars and black holes and things like that, the supermassive things or the super fast ones, when speeds are almost the speed of light, like, for example, inside a nuclear accelerator. So these things, they are not compatible. So these are models, really. Okay. So again, this is something that we need to understand. The connection also between physics and math, because there is like a connection between two. The biggest thing that you need to realize is physics is not math. But it uses math. So that is something that needs to be clarified, and we have to also have an understanding of that. We need to understand, since we talked about measurements, we need to understand how we measure things. And it turns out we measure things with these four letters. Meters, kilogram, second, and ampere for current. Now, this covers everything. Waves, mechanics, laws of motion, electricity and magnetism, modern physics, they're all inside these four letters in terms of measurements. These are known, the metric system, and this is what constitutes what is known as SI, which is coming from the French words Système International. Okay, but again, it's used now as a standard in how to measure things in physics. Okay, and again, part of the objectives of this class too is to be able to do labs So labs constitutes a big chunk of your grade. And as I was saying, or observations. I mean, it's really an experiment is the foundation of all physics. If we don't do labs, we're not doing physics. We may be doing some other things. Okay, so that's why it's important that we have to have that. And then one of the things that you should be able to understand and do well at, one of the skills that are required for this class is lab reports. It's not just the report itself, really. It's to be able to express yourself, express your view in a scientific manner. So that's what the purpose of the report is. You're going to have some sort of an objective. What are we doing today? What are we measuring today? What do we want to do today? So we should be able to express that clearly. This is what we're doing. And then how are we doing it? Obviously, you're going to be given the lab manual. So it's going to help you a lot because it's going to tell you what to do. Okay. So, and then you're going to collect the data. Once you collect the data, you should be able to analyze the data. You should be able to graph the data. You should be able to average it, for example. You should be able to find something off of that data. The data will tell you things. It will talk to you. If you're careful enough, you're going to hear it and translate that language through your report. Okay. So once you have that, you have actually come up with the results. Now, remember your objective. You have to really relate back to it. Did you meet it? Did you do what you're supposed to do? Today, for example, we're measuring the speed of sound. How are we going to measure the speed of sound? Are we going to take sound and track it and see how far it's moving? That's hard. So what we do actually in this lab, actually the lab 1, is basically what we're going to do is observe something called resonance phenomenon. That is a well-known phenomenon, and measure the nodes and NT-nodes. And once I find how much the separation between the two, that will give me measurement for the wavelength. So if I know the wavelength, and if I know the frequency, there is a nice relationship between the two that can give me the speed of sound, and that's how I'm going to find the speed of sound. And at the end, what was the speed of sound that I found? How does it compare to what other people think the speed of sound does? So that is part of my report. I should be able to explain these things. Again, we're not going to do all of this at once. So if it sounds kind of probably, where is my mouse for some reason? I have 3 screens, so I really don't know where the mouse is right now. Can I escape this? I know it's somewhere in here. Sorry about that. Okay, I can't find where the mouse is. So let me turn it off and on. Okay, I'm trying to exit this from this screen. For some reason, it's not letting me. Anyway, so if we're not going to do all of these things at once. So if you find it kind of too much, please understand that it's going to be in baby steps till we achieve all of these objectives. Does this sound good?
Yes.
Okay. Very good. So okay, I thought I saw the mouse somewhere in here. Anyway, so if you guys don't have any, do you guys have any questions first before I? Oh, I see it.
Yeah, I have a question.
Yes.
Just what can you expect your student week to look like in the class? Like, how should we delegate taking this class? You know, is it like normally around 4 hours of homework a week? What kind of expectations should I have?
Okay, you expect about 6 hours basically of work in general, because you have to go and read the chapters, okay, and you have to do the examples examples, and it tells you basically which examples you have to do. So you have to do those examples, and that is a minimum, okay? You may spend more time depending on what you have and what kind of other things that you're going to spend, you're going to do. The homework assignments, and it's a very good question, okay, that I am glad that you asked, is I don't want you to spend more time than you should on the homework. If you find yourself spending more than 5 to 10 minutes on a given problem, it's not that you give up, but please reach out for help. As I was saying, there is the STEM Center. You can reach out to me directly, okay? Hey, this problem, for example, I don't know how to start it, or it's not clear, or what should I do to get started or something, okay? Don't spend too much time on things like this ones, because I want you to really be moving, okay? But the reading is required. The examples in the book are required. And then also the assignments are required. And some of these assignments, they can be a little bit lengthy, especially in terms of the lab. You're going to spend about 3 hours in lab, and then you're going to compile those data and analyze it and report to it, okay? And I know I posted a video already for how to graph data using Excel or Google Docs. So if you still have any issues along those lines, please let me know so that we can expedite things. In the beginning, it's probably going to take more time, and down the road, it's going to be a little bit faster. Did this somewhat answer your question?
Yes, sir. Thank you.
Okay, very good. Very good. Any other question? I know what the problem with the mouse was. It was this pen. It was sitting on the hole. So it was blocking it. If you guys don't have any questions, I will post this for recording later on Canvas, and please bring them on as they come in. Okay, don't let something that is working in your mind, let it linger for more than what it should, okay? Reach out immediately. It doesn't have to be, even if you may think it's kind of an easy question or a silly question or something like that, there is no such a thing. Because the last thing I would want to see is that you're actually bothered with something because these things build up. It may sound little right now, but over time it's going to build up and it's going to hinder your progress in the course. Make sense?
Yes.
Okay, very good. So I know some of you are going to be meeting with me later on today at 4 p.m. So I'm going to see you later. The others, I'm going to see you in about, I should say, 2 weeks or so. Sounds good? Okay. Thank you, guys. I'm going to end the recording.
Thank you.